The gamma function is known to satisfy gamma of x times gamma of 1 minus x is equal to pi divided by sine of pi x. And this works for any non-integer x, so you can't plug in 1 or 2 or negative 3. Okay? But they're giving us this relationship. It's quite an important relationship if I'm remembering my analytic number theory correctly, but that's a little more advanced than what we're just talking about right here. We want to use this relationship to figure out what the value of gamma of 1/2 is. Okay, so just from this relationship, can we work out gamma of 1/2? Well, 1/2 is at least not an integer, so I could plug it in. I mean, this relationship will tell us something like gamma of, let's think of something, gamma of square root of 3 times gamma of 1 minus square root of 3 is equal to pi over sine root 3 times pi. Okay, that's a relationship. So if I knew for one, I could solve for the other. So maybe there's a way to plug in 1/2. Okay, should it go in for the x? Okay, or maybe should we try and get the 1 minus x to be the 1/2? Okay, or maybe we need to use the recursion formula. Well, let's just try x is 1/2 and see what we see. Okay, just experiment. Maybe this will work, maybe this will fail, maybe it'll fail miserably, or maybe it'll fail in a constructive way. So we'll just say let x be, I'll write this in the proper order. Okay. If it's constructive, maybe we'll learn something about what we can and cannot do with this. Okay, what might or might not be helpful. But let's just play around with it. We're asked for gamma of 1/2, let's make sure it appears in our equation somehow. So we get pi over sine pi times 1/2. Make that top pi look a little less exotic. There we go. Now 1 minus 1/2, quite interestingly, is just 1/2. So when you plug in x is 1/2 into this formula, you get gamma of 1/2 squared. So that's the value we have over here on the left-hand side. Okay. And sine pi by 2 is just 1, so gamma of 1/2 squared is just going to be pi. So gamma of 1/2 should be, well, it's plus or minus square root of pi. Okay. Is there more work we can do to work out if it's going to be positive root pi or negative root pi? Well, let's for a second think about the actual expression for gamma of x. You integrate from 0 to infinity, t to the x minus 1, e to the negative t. Right? So gamma of 1/2, gamma of 1/2 is going to be 0 to pi t to the 1/2 minus 1, so negative 1/2, e to the negative t. But e to the negative t is always positive. And this is 1 over root t, and as long as I plug in positive values, this will only be positive. Okay. Now, knowing that gamma of 1/2 exists, this should converge, okay, which means it represents an area under a curve, but this curve here is always greater than 0. Right? And so how could the area possibly be negative? So the area is positive, and that means that gamma of 1/2 isn't going to be negative root pi. It's just going to be regular root pi. Okay. And that gives us our answer. So we started out playing around with this formula very innocently. It happened to work right away as soon as we plugged it in. That was fantastic. Okay. Undoing the square, we were presented with 2 options, and then we had to go back to other things that we knew. Okay. In this case, the type 1 improper integral definition for our gamma function. And we worked with gamma of 1/2. And said, well, it's got to be positive. And there we go.